All right, so we measured our closed cell foam, and now we're going to measure a different type of material. This is a polyethylene substrate, which is quite thin. It's around 21 to 22 microns thick, and it's a different dielectric constant, so we're going to have to recalibrate the system to be able to measure to this type of material. We essentially left our setup the same as before. We're at a 3 millimeter gap. So what we're going to do, we were measuring mils before, thousandths of an inch. So we're going to go into display settings and we're going to change that from mils to microns. Hit OK. So now we're measuring microns, and we're going to have to go in and do our calibration. So we go back to the measurements tab here, set up channel 1. And with nothing in the gap, we check our gap, by the way, and we're still sitting at 3 millimeters, which we were before. Nothing's in the gap, as you can see here. And we're going to tell it that there's nothing in the gap. Thickness of the material in the gap is 0. I hit calibrate, and the software does its thing and enters that in there. And then the next measurement we're going to make is we're going to slide the polyethylene material in there, and we're going to tell it it's 21 microns thick, which is, we measured this with a precision micrometer. And we're going to enter 21 microns in here and hit calibrate. And it takes the software a couple seconds to set the calibration. The nice thing is you don't have to know what the dielectric constant of the materials is. This essentially takes care of that for you as long as you know the thickness, which is quite easy to do. And we can see up in our window right here that we are measuring 21 microns, which is what we told it the thickness of this is. And as we move it around, the sheet around, we can see that it changes a little bit. All right, we're down about 17, 18 over here, 18 there. 18 there, go back to the center, and we're back to 21. So we can see that there is some variation in this sheet. And we can also click on our settings. What we're going to do is put our measurement axis settings to automatic, hit OK. So we're going to let the computer figure out the scale factor for us. And we're going to hit start here and start looking at it, and you can see there's quite a large variation here, and that's because it's not moving. We're stopped, so we're essentially looking at system noise. Once we start moving, the auto scaling is going to change that scale up, which it just did there. I must have bumped the table. And I'll move the sheet around, and we can see we're sitting at about a little below 21 here at the middle. But as I move it around, the auto scaling, all right, allows us to not have to set the scale factor in. It'll do that for us. So I've moved it to all 4 corners and then back to about the middle here. So we can see there's a variation. Let me stop the graphing going on here. So we can see that, well, this bump set the scale kind of high, but you can see here that as we move the sheet around, we're picking up the differences in the thickness. And that's based on our calibration factor. So if you change dielectric constants or have different process runs and your dielectric constants changes, you'll need to have test coupons that are representative of the process you're using. And it's quite easy to stick these things in there and then recalibrate the system for the dielectric of the material that you're using. And that concludes our video on how easy it is to calibrate the digital AccuMeasure. If you have any questions, you can always give us a call or shoot us an email. We'll be glad to answer any questions you have on how to measure thickness of dielectric materials. We'll also add that we're going to have a slide in here on how to measure density of materials too. So we can measure thickness if you know the thickness. If you don't know the thickness and you're concerned about measuring the density of materials, which is a large measurement that people want to make, and what you would do is there's a specific mathematical algorithm that relates the density of a material to the thickness of the material and the dielectric constant, or the capacitance. In this case, we're measuring the capacitance, really. And by knowing the thickness using opposing lasers or something like that, you can compute the density of the material without having to shut your line down and take a sample out and go through an hour calculation in your labs to do that kind of thing. So look for that slide later on in this video.